Algebra 2, Chapter 10, Section 4, Infinite Geometric Series. So, in the last section, we talked about uh, the partial sums of geometric series. We had like S sub n of, what was it? A1 minus A1, or A sub n times R over 1 minus R. I think that was one of the formulas there. I probably should know that one. Pretty sure that's what it is. But the whole idea is, uh, what do you do if instead of stopping, you have an infinite number of terms? And I really do mean infinite. I mean you add an infinite number of numbers together. What happens? Well, two things can happen. Either it has a sum, and we call that a convergent series because it goes to a specific value. Like you add up an infinite number of things together and it equals 2. It doesn't seem like it should be a thing. I mean, you're adding an infinite number of things together, but we're going to find that some of them add up to a very specific value, one that we can calculate. There are, of course, others. If they don't have a sum, we call it a divergent series. Okay. If you remember, a geometric series was very much like a exponential function. And if you take a look here at the two, if you kind of look at the path of the convergent series, you notice it's like a logistic growth model. It kind of comes up to a point, and at a certain point, it just kind of stops getting any bigger. That's the value that it's going to sum to. So that's what a convergent series is going to look like. The way that you know it is that the common ratio, the absolute value of the common ratio, is less than 1. For a divergent series, you notice it looks like it's growing bigger forever, which means it's never going to add up to a single number. And you know you have a divergent series when the common ratio is greater than 1. So that's the big thing you're looking for, is the absolute value of the common ratio. Is it less than 1 or is it bigger than 1? Right? Fraction, like a nice fraction less than 1, like 4/5 or 1/2, or is it bigger than 1? Even 1.00000001, it's bigger than 1. That common ratio is divergent. But if you had 0.999999999, then you would have a convergent series. Weird, but true. All right. The first thing you got to be able to do is figure out whether or not you have a convergent or divergent geometric series. And the way you do that is by finding the common ratio. So let's take a look here at these terms. I have 36 divided by 54. Those both look like they're divisible by 6. And I see 6 over 9. Those are both divisible by 3. So how about 2/3? So if that's our common ratio, the absolute value of the 2/3 is less than 1. So this would tell me convergent. If you were add together that infinite series right there, you would come to a single value. Let's try the next one. Here I take second term divided by the first term. I know it's a geometric series, so I just have to figure out what the common ratio is. And I see I've got 12 over 8, which is, they're both divisible by 4, so how about 3/2? The absolute value of 3/2 is greater than or equal to 1. So this would tell me it is divergent. All right. And that's all you need to do to try to identify convergent or divergent geometric series. Find the common ratio.